If you slide the 7 continents back together, they lock perfectly into place as Pangaea. For over 100 million years, this sprawling, C-shaped landmass dominated the Earth. But Pangaea is not the beginning of the story. It is merely the most recent chapter in a relentless 4 billion-year cycle of continental assembly and destruction. This cycle is powered by plate tectonics. Early on, as massive slabs of Earth's crust collided, they generated immense friction and heat. Magma rushed upward from the ocean floor, solidifying to form our planet's first primitive rocky islands. Beneath those volatile islands, the continuous melting stripped away heavy elements. What remained were incredibly tough, deep-reaching roots of crystalline rock called cratons. Because of their rigidity and melt resistance, these cratons survived the violent tectonic activity of the early Earth. They eventually collided and stitched together, forming permanent building blocks, like the vast slave craton beneath modern-day Canada that still support our continents today. The collision and separation of these continental cores governs global chemistry. By redrawing ocean basins and shifting climate patterns, they have repeatedly driven early life toward extinction, forcing the survivors into their most significant biological transformations. Around 2.7 billion years ago, enough cratons had gathered to form Earth's first true supercontinent, Kenorland. Kenorland was a colossal, elongated wall of rock. Because it stretched so far from north to south, it physically blocked the flow of ocean currents that normally regulate global sea temperatures. Then, deep mantle shifts caused the landmass to violently rupture. About 2.5 billion years ago, Kenorland began tearing apart into smaller fragments. The fracturing of the landmass triggered heavy rainfall and accelerated rock weathering, which scrubbed carbon dioxide from the atmosphere. Without greenhouse gases, temperatures plummeted. Ice sheets spread rapidly, sealing the planet in the first snowball Earth. With the oceans iced shut, they couldn't absorb gases. Biologically produced oxygen became trapped in the atmosphere, its concentration surging upward over 100-fold. For the anaerobic microbes of the time, oxygen was highly toxic. That sudden atmospheric spike killed off more than 80% of all life on Earth. Survival required a new strategy, sequestering genetic material within a protective membrane to shield it from the highly reactive gas. This adaptation yielded the first eukaryotic cells, single-celled organisms with an internal nucleus that would eventually evolve into every plant and animal on Earth today. 1 billion years ago, the cratons slammed together once more into a new configuration called rodinia. By now, the damp, rocky surfaces were blanketed in primitive algae and fungi. Around 850 million years ago, a superplume of deep-lying mantle rock punched upward, ripping rodinia apart from underneath. As the fragments scattered, the expanding ocean basins increased evaporation, triggering torrential rainfall. This rain washed the remaining greenhouse gases right out of the sky, plunging the planet into a second deep freeze. It took millions of years for volcanic eruptions to replace the atmospheric carbon and thaw the ice. When the oceans finally opened up again, life scrambled to adapt to the new, nutrient-rich waters, spurring the Cambrian explosion and the first multicellular life forms. Fast forward to 330 million years ago. The supercontinent engine has assembled Pangaea, and its surface is crawling with complex insects, thick forests, and giant amphibians. But Pangaea's sheer size created a brutal climate. Enormous mountain ranges built up along the collision zones, blocking inland rainfall and leaving the vast interior of the continent a parched, hostile desert. Out on the coasts, Pangaea's massive C-shape cradled its interior oceans. This geography prevented cool Arctic currents from circulating in, overheating the coastal waters and destroying marine habitats. Between the scorched inland deserts and the boiling coastal waters, the environment collapsed. During the resulting Permian extinction event, more than half of all biological life perished. Yet this environmental clearing made room for new dominants. Among the few land survivors were highly adaptable avian lineage reptiles, who inherited an empty continent and eventually evolved into the dinosaurs. Pangaea's reign ended roughly 180 million years ago, when a massive rift divorced its northern and southern halves. Soon after, North America tore away from Eurasia, opening the Atlantic Ocean. Meanwhile, India broke free, hurtling north across the Indian Ocean before slamming into the Asian plate. The force of that direct collision buckled the continental crust upwards. The towering Himalayas are the lingering, physical scars of that exact impact. The world map we memorize in school is highly temporary. It is just a momentary snapshot of fragments in transit. The tectonic engine is still running beneath us. In about 250 million years, the Pacific Ocean will close entirely, slamming the continents back together to forge Pangaea Proxima, and dictating the next great leap in the evolution of life.